So welcome to my next walkthrough of one of the ROPemporium challenges. This time it's challenge number 3, callme. And in this video I will do the 64-bit walkthrough. And probably due to the length of the whole walkthrough, I'll do another one, a separate one for the 32-bit version. So when we unpack the challenge, we have in this directory we have both variants already, the callme and the callme32, as well as an encrypted flag, which is our file that we want to get the data from, and two SO files, which are called by the callme. That challenge had a little bit of a longer description, but basically you don't have to care about this key1dat, key2dat, or the lib files. Basically all you need to do is to call the three functions callme1, callme2, callme3 in a row, each of them with a parameter of 1, 2, 3. So that's all. So let's have a look and see what callme looks like in GDB. So we have the following functions. As you can see, we have callme3, we have callme1, callme2, and so on and so forth. And we have useful gadgets and useful function. Let's have a look at this one. Useful gadgets. Indeed, this looks promising. We have 3 pops here in a row, followed by a red. And what is the useful function? Okay, basically this is an example how to how to call that function actually in 64-bit, because in 64-bit the parameters are delivered via the registers. So the first parameter is in RDI or EDI as in here, the second in ESI or RSI, and the third one in EDX or RDX. So this can serve as an example. So we need to get the values 1, 2, 3 in our case instead of 4, 5, 6 into these registers, and then callme 3 to 1 in a reverse order as well. So as in the previous challenges, we have a function called pwnme, which has here a nice buffer overflow, because fgets reads as much as we want to, and basically all we have is a variable stack space of 32 characters, or hex 20. So we can create a buffer overflow like in every of these challenges. So that's not really a big thing to do. In the 64-bit version, this will be our buffer overflow, and what comes after this BBBBB is then our overwritten return pointer. So let's first sketch out what we want to achieve. We want to call callme1, we want callme2, we want callme3, and each of these should have these parameters delivered as in here. Well, that being said, the easiest one will be to use that useful gadget function with the pops, because in that case all we need to do is to put this gadget here on the stack, return to it to execute it, and then the next 3 parameters on the stack will automatically be delivered into these registers, so RDI, ESI, and RDX, as you can see here. So all we need to do is to place after that function call the parameters 1, 2, 3 on the stack, and then our address of the callme1, callme2, callme3. So let's sketch that out. So we need gadget 3 times the pop. Then we want to have our values on the stack, callme1, callme2, and that's it. Okay, so then let's do that. So our gadget is this one here. So we will need to have this address on the stack. So in reverse order it is xb. We want to write it with echo again. That's the easiest variant. So, and as we are in 64-bit, we need to have 8-byte long versions of our addresses. So then it's x01. The rest is zeros. I'll show you in a second why I'm actually doing it like that. The end here, of course, like this. 4, 6, 7. Then we have the 2s and the 3s. And then our calls. And we can basically copy that one here, replace this one, and replace this one. So, and callme 1 to 3, we have it right here. So callme 1 is at 40, 18, 50. So this is our address here, 1840, and a 0, and 4 more. And for callme 2, we have 40, 18, 70. And for callme 3, we have 14, 18, 10. Okay, so now I'm super daredeviling. I'd like to try it just like that. Oops. So this is our buffer that we want to send, but of course we need to actually replace all the new lines in it. So this one looks quite promising. We have here our pop call. Then our 3 values on the stack, each 8-byte long. Then we have our call to callme 1. Another 3 pop, 1, 2, 3, callme 2, 3 pop, 1, 2, 3, callme 3 again. So let's try. And here is our flag. So let's look at it in GDB. We already see now that our code worked. So pwnme, we break at pwnme plus 79 for illustration purposes, and then read from our input file. So what we see here is actually we break after on the knob. As you can see, RSP, RVP are overwritten, which is no secret. And the next thing that we will jump to after the red will be our gadget that we placed on the stack. So we can see it here also in the succession graphs, which is very nice. So we have the 3 pops in the red, and then it will jump to callme 1, callme 2, and so on and so forth. And as you can see here also on the stack frames, you can see it's nicely laid out. So useful gadget, our pop, 1, 2, 3, callme 1, useful gadget 1, 2, 3, call me 1. So let's break on call me 1 for illustration purposes. And okay, let's single step. So as you can see on red, we will jump to our gadget, this one here. So we are in our gadget now, in midst on the pops, pop RDI, pop RSI, pop RDX. Pop RDI will take the top of the stack where RSP is pointing to and put it into RDI. The top of our stack is this one here, so it's the value 1 as desired. Once it has been popped, RSP will point to the next one, 8 bytes further away. So this one will point to the 0x, 02, sorry. So, and we repeat the command, single instruction, and yeah, then that's the pop, last one. And we will now return, and return will return to what's in our RSP then. It will then call me 1. Exactly, and what we see here is the PLT entry with the trampoline, and this is the actual call that we'll do. That's the beginning of call me 1. So, well, let's single step onto we'll read the parameters. So we make room on the stack for 20 more bytes. That's exactly this one here. So from E8 to O8, that's our hex 20 bytes, 32 bytes for 8-byte double words, quad words. Oh, I never know. And here we can see now that we will populate our registers with the corresponding values. So RDI will have the value 1, ESI will be put into the next one, and so on and so forth. Exactly. So, and okay, we can break on call me 2 once more, continue, and it's basically exactly the same. So this was not too much of a problem. We get our flag, and we're done. Thanks for watching.